If my voice is audible to you, then respond into the chat box so we can start with the discussion. As I can see that 4 students are only there in the session. अभी तक 4 ही student join हुए. What about the other student? Please let me know into the chat box. What about the other students? This is the EPVOS lab of the chemical diploma students. And what we discussed in the last lab, any one of you? Any one of you, what we discussed in the last lab? तो बता पाएगा चैट बॉक्स में अंदर के लास्ट सेशन में के अंदर क्या डिस्कस हुआ था? नहीं याद छे? First of all, we are going to focus on revision part. रिवीजन पार्ट पे फोकस करेंगे. तब तक किसी को कुछ याद हो रिगार्डिंग द डिस्कशन दैट वी हैड इन द लास्ट सेशन, I request you to drop your responses into the chat box. Correct. Aryan, your answer is correct here. Waiting for other students to respond regarding what we discussed in the last session. Giving you 3 to 4 minutes to respond. Any one of you? Correct. Aryan has already. So Aryan, even apart from that, we also discussed one more topic. एक और topic भी discuss हुआ था. So if you can answer that question, then that it would be very great from all of you on your side. It would be great if you are able to answer that question. We discussed something about induction motor, if you remember. हमने इंडक्शन मोटर के बारे में कुछ डिस्कस किया था. So if you can just respond into the chat box that what we discussed about the induction motor and let me know into the chat box. क्या डिस्कस किया था इंडक्शन मोटर के बारे में? Waiting for a response into the chat box. A Colvin, you didn't remember it. Oh, yeah, it's fine if you don't remember it. No need to worry. And I think I gave you the book in the last session. मैंने already आपको एक book भी दी थी. So hope you are having that book with you. Okay. So in the last session we had a discussion on the induction motor. How many types of induction motor are uh, there that we discuss? કેટલા ટાઈપની ઇન્ડક્શન મોટર છે એ આપણે ડિસ્કસ કર્યું હતું. એનું કન્સ્ટ્રક્શન પણ આપણે ડિસ્કસ કરેલું હતું. અને basically there are two types of motor. Induction motor. One is the single phase induction motor and second is the three phase induction motor. And the second important thing about the induction motor is an important part about the induction motor is construction and single phase and three phase induction motor apart from squirrel gauge motor is there as well as the second type of motor is there is the wound rotor. So that any motor discuss करेंगे squirrel cage induction motor and the wound rotor induction motor. So all of you, what is the difference between squirrel cage induction motor and wound rotor induction motor? Please respond your answer into the chat box. Giving you 2 minutes to answer this question. Please let me know into the chat box if you remember something out of it. Otherwise, I will be starting with the new uh, discussion, which is very important. And I will be sharing you the new concept, new theory, new practical I'm going to show you, which is very important when it comes to the practical. And that is all of about the your again first I will not be starting that discussion right now, but first of all I'm going to give the brief of the last session. पहले उसका एक brief दे देता हूँ. Discuss about the induction motor and what we are going to discuss today. If you're able to see the syllabus on your screen, then respond into the chat box. If you're able to see the syllabus on your screen, then respond into the chat box. Okay. So just look at this. This we discuss about the various electrical quantities. આપણે દરેક ઇલેક્ટ્રિકલ ક્વોન્ટિટી એટલે વોલ્ટેજ કરંટ પાવર અને બધા પેરામીટર કેવી રીતે મેઝર કરવા that we discussed. How to measure the voltage, current, power, and other parameter that takes is or that thing is already discussed with you. Secondly, we discuss about the working and construction operation of electrical motor. તો આપણે મોટરનું વર્કિંગ, એનું કન્સ્ટ્રક્શન મીન્સ કે કઈ રીતે બનાવવામાં આવે છે, એની અંદર કયા કયા પાર્ટ છે, એ બધી વસ્તુ બી આપણે એકવાર જોઈ લીધી છે. That this part is already has been discussed with you. Now, we are going to have a discussion on this practical working construction and operators or electrical transducers which used or which are used for the measurement of flow. So let me put it on your screen. So today's agenda is, and today we are going to discussion or we are going to have the discussion on this topic. आज हम ये टॉपिक पे डिस्कशन करने वाले हैं, और in that topic we are going to discuss that how we can measure the flow. Flow means, flow નો સિમ્પલ મીનિંગ છે કે પાણીનો જે કેટલું, let's say, how much liquid is passing per minute, that we are going to calculate. The meaning of flow is, flow નો meaning છે કે કેટલું પાણી વહી રહ્યું છે એક સેકન્ડમાં, કોઈ liquid કેટલું વહી રહ્યું છે, એ આજે આપણે શીખવા જઈ રહ્યા છે. Because in your branch, in your chemical engineering, the proportion by which you are mixing the liquids, that is very important. So you need to measure the flow. Let's say if I'm saying that you need to mix 100 ml water with the 200 with the 10 ml of the lemon, with the 10 ml lemon. So the 10 ml is very important. So if you increase the 10 ml to 11 ml, then the taste of is going to be changed, or in your words, concentration of the liquid is going to be changed. Suppose હું તમને એમ કહું છું કે 100 ml પાણીમાં 10 ml લીંબુ નાખવું છે, તો એ 10 ml લીંબુ માંથી જો તમે ભૂલથી 11 ml કરી દો, તો શું થાય? તમારો ટેસ્ટ આખો ચેન્જ થઈ જશે, અને તમારા લેંગ્વેજમાં એને શું કહેવાય કે ભાઈ લિક્વિડનું કોન્સન્ટ્રેશન અલગ થઈ ગયું. ખ્યાલ આવે છે વસ્તુ? Is it clear? Are you getting my point, students? So that is why flow is very important. The liquid or the liquid which is passing out from the system, the measurement of the liquid which is passing out from the system, it is very important in your system. That part is very important. Is it clear or it is not clear? That is why we are going to start the discussion now on the flow measurement. So before I start this discussion, let me share you some of the basics, not in the detail, because the material which I have for the flow measurement, that is very huge material I have. And this material is not for the syllabus, but just for your reference. Okay, so if you are able to see the slides on your screen, let me know into the chat box. તમારી સ્ક્રીન ઉપર સ્લાઇડ દેખાતી હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કરી દો. Okay, so today I'm going to show you the some of the basics of the flow measurement device and some of the sensors which are available to measure the flow. Okay, आज इसके ऊपर डिस्कशन होगा. Yeah, just look at this first sentence. It is very important in large number of industries. મોટી ઇન્ડસ્ટ્રીમાં ફ્લો બહુ જ ઇમ્પોર્ટન્ટ છે. જેમ કે દવાની વાત કરું તો દવામાં જે તમે કોન્સન્ટ્રેશન જો 100 mg, 200 mg, 300 mg. So if you look at the medicines, even in the medicines, this they are available in the 100 mg, 100 milligram. 100 mg means 100 milligram, 200 milligram, 300 milligram. So this is the concentration of the things in your medicine. So it is done for determining the proportions and amount of material in out of the process. So this is very important. Flow measurement is very important in the plant operation. So in the chemical industry, it is very important. Plant material balance, quality control, and continuous process would be important without the flow measurement. So again, some of the processes are uh, without the flow measurement, it will be useful, or it will not be useful. Just let me give the example. If I talk about the curd means dahi nahi baat karo. And if you have taken the curd from the Amul company, have you have you observed any change in the taste difference of the curd of Amul? તમે જે અમૂલનું દહીં લો છો એમાં તમે કોઈ દિવસ એનો ટેસ્ટમાં ચેન્જ ઓબ્ઝર્વ કર્યો છે કે નથી કર્યો? Just let me know into the chat box. Even if I say the chocolate flavor milk, which is sold by Amul company, I'm talking about the chocolate chocolate flavored milk, which is sold by the Amul company. Have you seen any taste change in that flavor throughout the year? Suppose you are drinking that Amul chocolate milk from Ahmedabad, and if you are drinking the same chocolate milk from the Rajkot, have you seen any difference in the taste? Obviously, no. તમે ચોકલેટ મિલ્ક જે તમે પીવો છો એમાં કોઈ દિવસ ટેસ્ટમાં ચેન્જ નહીં આવે. The reason is they already define the how much. Suppose they are preparing the thousands liter, 1,000 liter chocolate milk at a time. So they already define that how much they are going to add the chocolate, how much they are going to add the water, how much they are going to add the chocolate, sugars, all the levels are defined. So when let's say if they're saying that they want to add 100 ml of the this thing, so that 200 ml measurement is very important. If you are changing that ml by the 1 ml even, then it will not keep the taste same. So this is very important. Up to this point, if you are having any query, any doubt, then let me know into the chat box. Okay. Sorry, I got one emergency call for a minute, so I need to take it. So, types of flow rates. So there are some methods only applied for the liquids. Some methods are used for the gases, and some methods are used for the vapors. So again, flow measurement, it's not common for the liquid. Flow also important for the gases, vapors, and everything. So flow can be a turbulent or the laminar. Turbulent. This is very important. તમારા flow બે type ના હોય, turbulent અને laminar. And I will explain you what is the difference between these two. આ બંને વચ્ચેનો શું ડિફરન્સ છે હું તમને એક્સપ્લેન કરીશ. No need to worry. Flow rate can be changed from few drops per hour. It's like your tap. તમારો નળ જે તમે યુઝ કરો છો, જે ઘણી વાર તમે પ્રોપરલી બંધ ના કરો તો ધીરે ધીરે પાણીનું ટપકું પડ્યા કરે. So this is the about your tap which you are using daily in the practice. So if you are not closing it properly, that you know that water that droplets falling from it. And 1,000 gallons per minute. The characteristics that need to be considered for the flow measurement. એટલે flow measurement કરવા માટે કેટલા કેટલા પેરામીટર ઇમ્પોર્ટન્ટ છે. And that parameters are on your screen. First parameter is the viscosity, density, and the compressibility, and pressure and the temperature. So suppose તમારે flow measure કરવો હોય તો તમને આટલા પેરામીટર તમારા લિક્વિડના ખબર હોવા જોઈએ કે કેટલું ડેન્સ છે. ડેન્સ એટલે કેટલું વજન છે. If I give the example, 1 liter petrol and 1 liter water. તમને એક્ઝામ્પલ આપું કે 1 લિટર પેટ્રોલ અને 1 લિટર વોટર બંનેનું વજન સેમ હશે. The weight of 1 liter petrol and the 1 liter water is same or different. Waiting for a response into the chat box. Why same? I'm not able to listen. It depends upon the its density. કે પાણીની ડેન્સિટી અને વોટરની ડેન્સિટી સેમ નથી, અલગ અલગ છે. So ultimately weight depends upon the density. Okay. Now methods, inferior, the flow meters are there. 25 voltmeters are there. Mass flow meters are there. Now we are not going to study this in the detail because this is more related to the in detail study of the flow measurement. So the Reynolds numbers is very important. Reynolds numbers is very important. And here the Reynolds number indicate is available from the fluid velocity, its density. It depends upon. So if your Reynolds number is more than or above 2300, Reynolds number 2300 and turbulent and above the turbulent flow. So if your Reynolds number is more than 2300, then your flow will be turbulent. So this is very important, that thing that you should keep on your mind. The value of 2300 has been determined experimentally and is certain the transition between the laminar and turbulent flow. Now just look at this. So let's say if you are passing the oil, and if I talk about the water, પાણી અને ઓઇલની વાત કરું તેમાં ડેન્સિટી કોની વધારે હશે? If I talk about water and oil, which liquid has a higher density? Which liquid has a higher density? Waiting for a response into the chat box. I'm talking about the two liquids. One is the oil and second is the water. So which one has a higher density? Let me check the chat box for a responses. I'm talking about પાણી અને ઓઇલમાંથી કોની ડેન્સિટી વધારે હોય? ઘનતા. Yeah, correct. Calvin, your answer is correct. ચલો, પાણી અને ઓઇલ માંથી કોનું વજન વધારે હશે? ચલો, હવે આન્સર આપી શકશો? Correct. Just your answer is correct. Okay. So, if you pass the oil from the any pipe, it will have the flow like this. તમે જ્યારે કોઈ ઓઇલ ને તમે કોઈ પાઇપ માંથી પાસ કરશો એનો ફ્લો કંઈક આ રીતનો હશે, and that is known as a laminar flow. એને laminar flow કહેવાય. And if you pass the water from the any pipe, then it will have the flow like this, which is on your screen, and that is known as a turbulent flow. Okay, is it clear? Or it is not clear? Okay, okay. So this is very important that you should understand the difference between this flow. Okay. Now, after understanding the flow, so that this is very important. Laminar flow is of the type of the fluid, gas, and liquid flow in which the fluid travels smoothly or in the regular paths. In contrast to the turbulent flow, in which the fluid undergoes the irregular fluctuation and mixings. In laminar flow, sometimes called the streamline. Streamline means it will be uniform. Just look at streamline flow. તમારો કેવો હોય? બધી બાજુ જે ફોર્સ જનરેટ થાય છે લિક્વિડ જ્યારે પાસ થતો હોય ત્યારે યુનિફોર્મ. This is the difference between these two flows. Okay. Now, let's move further in the discussion. Just look at the example of turbulent flow. તમારા સ્ક્રીન ઉપર turbulent flow નો example આપેલો છે. On your screen, flow of example of flow of turbulent flow is on your screen. Again, I'm going back and showing you. Just look at this portion. On this side, you should observe this portion. I'm going back and coming to this side again. Now, going to the next part. So, what is the basic requirement of flow measurement? Flow measurement की basic requirement શું છે? First is to uh, at calibration, integrate the flow fluctuations. Let's say, for the example, nowadays, if you talk about oxygen cylinders, which are very into demand. So and here, sometimes we are saying oxygen level is less in the hospitals. So they're talking about that overall flow which is there coming out from this oxygen bottle has to be a different. Some patients require 5 liters, 10 liters, 2 liters. So that is the flow. So in that case, flow measurement is very important. Easy integration with the piping system, high accuracy, high turn down ratio, low cost, low sensitivity, and the low pressure losses and moving parts. So these are the basic requirements. Now, definition of various quantity, velocity, you know about the velocity, meter per second. So similar way, velocity of uh, here liquid will be it will be distance per time. And next is the volume. You know about the volume. Volume is equal to cross section area multiplied by the uh, velocity of the fluid. So let's say even by measuring the flow, what you can find out that how much liquid has passed in the 1 second. मैं आपको simple example देता हूँ. I'm giving you simple example. Suppose if your tap is open, listen my sentence carefully. If your tap is open and per second 1 liter liquid is coming out, 1 liter liquid is coming out, then what will happen after the, or what will be the total amount of liquid that will come out after 1 minute? If your tap is open, જો તમારો નળ તમે ખુલ્લો રાખો અને એમાં પ્રતિ સેકન્ડે 1 લીટર લિક્વિડ બહાર આવતું હોય, 1 મિનિટ પછી ટોટલ કેટલું લિક્વિડ બહાર આવશે? Waiting for a response into the chat box. Waiting for a response into the chat box. All of you. Should I repeat my question or should you heard it? If you want to repeat the question, that drop the message, repeat into the chat box. Okay, okay. So if your tap is open and from the tap, uh, 1 liter liquid is coming out per second. So what will be the total amount of liquid that will come out after the 1 minute? જો તમે તમારો નળ ખુલ્લો રાખો અને એમાંથી પ્રતિ મિનિટે 1 લીટર લિક્વિડ બહાર આવતું હોય, તો 1 મિનિટ પછી તમારા નળમાંથી ટોટલ કેટલું લિક્વિડ બહાર આવશે? Question is already repeated second time. અમારા પાણીના નળમાંથી દર 1 સેકન્ડે 1 લિટર લિક્વિડ બહાર આવતું હોય તો 1 મિનિટ પછી ટોટલ કેટલું લિક્વિડ બહાર આવશે? Correct. So this is how you can measure the total liquid. So again, if if you are able to, so 60-liter liquid will be able to come out from your system. So what is important over here? So if you are measuring the flow, what is the second advantage? Second advantage is you can also measure the total number of how much liquid passed from your system. If you look at, we're talking about that, that this much liquid, 1 liter, 2 liter, 3 liter. So this is why this measurement is of liquid is very important. Is it clear or it is not clear? Okay. So let's move further in the discussion. So what is the conclusion of this theory that we can, with the help of liquid, with the help of flow, we can also measure the how much flow of liquid has been passed from the system. Now, this is the first meter. This is the basic method by which we are measuring the flow, and the method name is differential flow meter. તમારી સ્ક્રીન પર એક મેથડ છે અને એ જે મેથડ છે એ મેથડમાં શું આપેલું છે તમારી સ્ક્રીન પર કે તમારી અલગ અલગ જે મેથડ છે ફ્લો મેઝર કરવાની એમાં પહેલી મેથડ છે ડિફરન્શિયલ ફ્લો મેથડ મેઝરમેન્ટ. Now what is the differential flow meter method? So here in this method we are obstructing the fluid, and by obstructing the fluid we are creating the pressure difference, and by that way we are measuring the flow. Repeat કરું છું કે આપણે જે ડિફરન્શિયલ ફ્લો મેઝરમેન્ટ મેથડ છે એમાં આપણે શું કરીએ છીએ? આપણે ફ્લુઇડ ને ઓબ્સ્ટ્રક્ટ કરીએ છીએ. જસ્ટ લુક એટ ધીસ. પાણી એટલે જે તમારું લિક્વિડ છે એને રોકીએ છીએ અને રોક્યા પછી પ્રેશરનો ડિફરન્સ ક્રિએટ થાય છે અને એની હેલ્પની મદદથી આપણે કરીએ છીએ ફ્લો મેઝરમેન્ટ. અહીંયા સુધી કોઈને કઈ ડાઉટ હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કરી દો. What about the black dogs? Okay, okay. આર્યન, તું કયા બ્લેક ડોગ્સ ની વાત કરે છે? પ્લીઝ લેટ મી નો ઇનટુ ધ ચેટ બોક્સ. Okay, yeah, this is just example. They are obstructing. A black dots means some of the suspended particles inside your liquid. Okay, okay. આ છે આની અંદર suspended particles છે. So differential pressure flow meters are use the Bernoulli's equations. I'm not going into detail of this because this will be very difficult for all of you. So here pressure drop across the construction is proportional to the square of the flow rate. So simple way, the here we are going to create the pressure drop. So differential pressure flow meters introduce the constriction in the pipe, creates the pressure drop across the flow meter. Okay, and by that flow difference, with the pressure difference, we are going to measure the flow of liquid. Just look at this. So here you can just look at this example. These are the some of the things, some of the equations which will be used during the measurement, and with the help of that you can get the values of the flow, and with the help of those values you can find out the flow which is going in your system. Moving to the next part, this is the equation, or this is the again one more representation, that here we are obstructing the fluid. Just look at, here the pressure is D1, the P1, and here the pressure is P2. Due to this obstruction, અહીંયા આપણે તમને દેખાય અહીંયા પાઇપ નાનો થતો હોય છે, એટલે અહીંયા પ્રેશર અલગ હશે અને અહીંયા પ્રેશર અલગ હશે, અને એના કારણે જે લિક્વિડ જે સેટલ થાય છે તમારું, this is a mercury liquid which is setting up into the tube, and you can see the height difference. So height difference is, if we can convert this height difference into the velocity, and you can always convert the velocity into the liter. So again, a U-tube manometer is attached with the Venturi flow meter as shown in the sketch. So this is the, I will discuss this. I will discuss, not to worry. And the gauge fluid mercury with this density of this gauge H is 10 mm, calculate pressure difference around the P1 and P2. So by just looking at the temperature difference between these two, we can find out the what is the flow which is going inside the pipe. આપણે આ રીતે જે પાઇપમાં લિક્વિડ જે સ્ટેબલ થાય, બંનેની વચ્ચેની હાઈટ માપીને આપણે શું ફાઇન્ડ કરી શકીએ છીએ, કેટલો ફ્લો પાઇપમાંથી જઈ રહ્યો છે તે આપણે ફાઇન્ડ કરી શકીએ છીએ. Okay, now moving to the next part. Let me show you the different parts of differential flow meter. Now there are different types of differential flow meter. એટલે આ એક કન્સેપ્ટ છે, એ કન્સેપ્ટની ઉપર ઘણા બધા differential flow meter બનેલા છે. This is the one basic concept of the measurement of flow, and based on that concept different meters are developed. Okay, so if I give the example, temperature measurement. So temperature measurement has not a one limited application. Temperature measurement is very important in all this, on all other applications, जैसे कि temperature measurement of room, temperature measurement in your mobile, temperature measurement of your vehicle. So these are all the applications, but the the method of measurement or the sensors which are used in all this measurement, they might be a same. Are you able to understand કે સપોઝ હું તમને ટેમ્પરેચર મેઝરમેન્ટની વાત કરું, તો ટેમ્પરેચર મેઝરમેન્ટ કોઈ એક જગ્યાએ ઇમ્પોર્ટન્ટ નથી, એ ઘણી બધી જગ્યાએ ઇમ્પોર્ટન્ટ છે, પણ એ બધામાં જે સેન્સર્સ યુઝ થતા હશે એ સેન્સર તો અમુક જગ્યાએ કોમન જ હશે, બધી જગ્યાએ કોમન હોવા જરૂરી નથી, બટ ધ મેથડ ઓફ મેઝરમેન્ટ વિલ બી ડિફરન્ટ. અમુક જગ્યાએ સેન્સર્સ બીજા યુઝ થતા હોય. So this is the one of the, but the fundamental will remain same. Fundamental part हमारे ऐसे same. Okay. Now moving to the so differential flow meter has a two parts, primary and the secondary part. Secondary element. Primary element is used to limit the fluid. Primary element is used to limit the fluid. fluid flow in the pipeline in order to produce the differential pressure. So this is the first application of the differential flow meter. The different primary elements are, so this is very important. Primary element નું basic function શું છે કે liquid ને કઈ રીતે obstruct કરવું જેથી pressure નો difference create થાય. So the basic function of primary element is to how to obstruct the fluid so they can create the pressure difference in the system. So this is the basic function of the primary fluid. So the different sensors are orifice plate, venturi tubes, flow nozzles, dial tubes, and pitot tubes. So these are the various methods by which we can obstruct the fluid. આ જે મેથડ્સ તમારી સ્ક્રીન પર છે એક શેની મેથડ છે જેનાથી આપણે તમારા ફ્લુઇડ ને obstruct કરી શકીએ. These are the different methods by which we can obstruct your fluid. Secondary elements are those elements that measure the differential pressure produced by the primary elements. એટલે સેકન્ડરીમાં શું આવશે કે તમે એકવાર લિક્વિડને ઓબ્સ્ટ્રક્ટ તો કરી લીધું, you obstructed the liquid at the first stage, but at the second stage what you need to do, you need to measure the flow. So you need a secondary element which are going to measure that flow. તો બીજા લેવલે આપણે શું કરવું પડશે, પહેલા લેવલે આપણે લિક્વિડને ઓબ્સ્ટ્રક્ટ તો કર્યું, પણ બીજા લેવલે આપણે શું કરવું પડશે, એ ઓબ્સ્ટ્રક્ટ કરેલા લિક્વિડમાંથી ફ્લો કેવી રીતે કાઢો એના માટે ડિવાઇસીસ જોઈશે. એટલે તમારા ડિફરન્શિયલ ફ્લો મીટરમાં બે ટાઈપ્સના ડિવાઇસીસ આવશે, પ્રાઇમરી અને સેકન્ડરી. Just look at this. Now orifice plate, let me show you orifice plate. Let me show you the actual orifice plate. હું તમને orifice plate બતાવું છું. Yeah, just look at this. The device which is on your screen, the name of the device is the orifice plate. And how we are going to place between the pipe? We are going to place like this between the two pipes. Okay, એને કઈ રીતે પ્લેસ કરશું તમારી સ્ક્રીન પર દેખાય છે એ રીતે આપણે એને પ્લેસ કરીશું. Okay, so are you able to understand the basic of the orifice plate? તમને બધાને સમજો પડે છે કઈ રીતે બે પાઇપની વચ્ચે આને મૂકવાની છે? So we are going to put this orifice plate between the two pipes, and if you can do it, we are going to mount the meters over here which is going to measure the flow in your system. So this is how your orifice plate works. I'm not going into much detail, but these are the various construction. આ રીતનું એનું કન્સ્ટ્રક્શન આવે છે ને આ રીતે એને બે પાઇપની વચ્ચે મૂકવામાં આવે છે. Okay, is it clear? Please respond into the chat box. Okay. Yeah, this getting response from iron and the jigger. So orifice plate is the one of the uh, બેઝિક મેથડ. બટ વોટ ઇઝ ધ લિમિટેશન? આનું લિમિટેશન શું છે કે આની અંદર તમારો પ્રેશર ડ્રોપ બહુ થાય છે. permanent pressure drop is very high, and this is the one of the problem over here. And second is the this is generally of the metal, so corrosion is always the one of the problem in this orifice plate. Now, second construction to reduce the overall pressure drop in the pipe, and that construction that we used is the venturi tube. Now, just look at the construction of the venturi tube, how it is constructed. Just look at the construction. That here we are having the conical shaped pipe. Just look at the construction. So what is the advantage of the system? કે આનો એડવાન્ટેજ શું છે કે તમારી જોડે લિક્વિડને આપણે ડાયરેક્ટ ઓબસ્ટ્રક્ટ નથી કરતા. અહીંયા આપણે ગ્રેજ્યુઅલી પાઇપની સાઇઝ ડિક્રીઝ કરીએ છીએ. વી આર ગ્રેજ્યુઅલી ડિક્રીઝિંગ ધી size of pipe over here. So the obstruction will be not much higher in this case. So the permanent pressure loss which we had in the previous system, and in this system it will be different. Okay. So if you are having any query, any doubt up to this point, so this is the second method by which we can measure the and again the method of measurement is same, but the construction we improved. અહીંયા આગળ મેથડ તો તમારી એ જ રહી છે, પણ ખાલી આપણે ચેન્જ શું કર્યું છે, પાઇપની ડિઝાઇનમાં થોડું ચેન્જ કર્યું. એટલે પહેલા જે કન્સ્ટ્રક્શનમાં જે પ્રેશર લોસ આવતો હતો એ પ્રેશર લોસ આમાં હવે ઓછો થઈ જશે. Is it clear or it is not clear? Next is the flow nasals. Yeah, Kelvin, thanks for your response. Now let me show you the photo of the flow nozzle, so you will come across. Yeah, just look at. So this is the flow nozzles, which this is the nozzle, which is having the such kind of shape. So this will be placed between the two pipe. This nozzle we are going to keep between the two pipe. We are going to put between the two pipes. And with the help of this flow nozzle, what we can do, we can measure the flow. So here again one more advantage, that the permanent pressure loss which we had in the orifice plate, જે આપણને orifice plate માં જે limitation આવતી હતી કે pressure નો drop બહુ થતો હતો, એ અહીંયા આગળ ઓછો થઈ જશે. This is the one more thing, and this is how we are going to insert the flow nozzles between the pipe. Just look at the construction. Just look at the construction of this particular system, which is on your screen. Okay, moving to the next part in the discussion. Now let's move further in the discussion. Yeah, just look at. This is the actual construction of your flow nozzles, and this is how you are going to, it is going to work. Now let me show you a small video which I have regarding this. I have the, let me show you the flow nozzle first. Just a second. I'm going to share you the video on your screen. If you are able to see the video on your screen, તમારી સ્ક્રીન પર વિડિયો દેખાતો હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કર દો. Video is on your screen, yes or no? Okay, thank you.
The most diverse substances are transported and distributed in piping systems every single day. They can include solvents and chemicals, oil and gas, or steam.
Yeah, one of the major application of flow measurement is on the petrol pump. Yes or no? તમારું જે પેટ્રોલ પંપ પર જો તમે ફ્લો સેન્સર ના લગાડો તો તમે પેટ્રોલ મેઝર કરી શકશો? If you are not putting any sensors on your petrol pumps, then is it possible then you can measure the flow of water, like sorry, flow of petrol which is coming out in of your system?
For energy transmission, the fluids flowing through pipes often have completely different properties. Therefore, different principles for their measurement are required. One method is flow measurement, based on the differential pressure principle. Some 300 years ago, Swiss mathematician and physicist Daniel Bernoulli discovered the direct relationship between the pressure and speed of a fluid flowing in a pipe. Italian physicist Giovanni Battista Venturi also performed experiments on flow, and in 1797 he built the first flow meter for closed pipes, known as the Venturi tube.
Just look at the construction. Video is not on your screen. Any query in the video, please? Aryan, you said no.
Here is how this measurement method works. Differential pressure flow meters have an artificial restriction integrated into the measuring tube, illustrated here by the example of an orifice plate. Two holes are located.
Just look at the first is the orifice plate, which I talked about. Now you need to observe that how this orifice plate is working. Okay, just got the response into the chat box. Okay.
In the pipe wall, one before and one after the orifice plate. Two separate tubes connect these holes to a differential pressure sensor with its two pressure chambers separated by a diaphragm. The tiniest pressure differences in the flowing fluid can be precisely measured. If the fluid is not flowing, the pressure before and after the orifice plate is essentially identical. As soon as the fluid...
Just look at the fluid. Now they are increasing the speed of the fluid. And what is happening in the pipe? જો અત્યારે એ લોકો fluid ની speed વધારે છે અને તમે જુઓ કઈ રીતનું obstruction વધી રહ્યું છે. And just observe this part.
It starts to flow, its velocity around the orifice plate increases significantly because of the restriction in the cross-section. At the same time, due to the laws of fluid mechanics, the static pressure at this point decreases. Consequently, different values are detected in the pressure chambers of the sensor, a higher pressure before and a lower pressure after the orifice plate. This pressure difference is a direct measure for the flow velocity, and thus the mass and volume flow in the pipe. The higher the flow velocity, and the resulting drop in pressure around the orifice plate, the greater the differential pressure measured. In numerous industrial applications, the orifice plate covers many needs of flow measurement technology. However, other designs are available for certain measuring tasks to minimize undesired effects.
So this is the one of the important part. So here they are obstructing the fuel by the orifice plate. So this is widely used in the industry. But what is the limitation? આનું limitation શું છે કે આની અંદર જે permanent pressure drop છે બહુ જ વધારે. So see here the permanent pressure drop uh, in this is very high. So that is why they move to the next part. Just look at it.
Such as excessive pressure loss or abrasion of components due to solids carried in the fluid.
Just look at the laminar flow. Now just look at the laminar flow.
This demonstration shows that an abrupt restriction generates severe turbulence in a fluid. Nozzles with a rounded, funnel-like inlet.
So just look at, now I'm simulating. હું તમને પાછળની 20 સેકન્ડ of part બતાવું છું. I'm going to show you the last 10 seconds part again. What you need to observe, just observe the flow in the orifice plate and what is the flow in this flow nozzle. Orifice plate હતી ત્યારે કેવો flow હતો અને હવે orifice plate ને બદલે આપણે flow nozzle લગાવી ત્યારે કેવો flow થયો.
Clearly reduce turbulence and thus create less pressure loss. Nozzles are particularly suitable to higher flow velocities or to fluids with abrasive solid particles. Turbulence reduction is even greater with Venturi nozzles.
Just look at the Venturi nozzles. Even turbulence is reduced.
And finally with Venturi tubes, where the restriction is created by longer conical constrictions in the pipe wall. All these designs can be supplied with different restriction diameter sizes so that the pressure loss and the differential pressure generated can be optimized for the process conditions. Industrial flow measurement using differential pressure has been tried in.
Is it clear or it is not clear? This video which I show you, was it interesting or you didn't found it interesting? This is about the flow measurement. Okay. Yeah, let's move on. So next is the pitot tube. Yeah, this is very important. This is even now this pitot tube is the widely used in the aeroplanes. Let me show you. I don't have a picture of aeroplane. Yeah, just look at it. Have you seen such kind of thing on the plane? Yes or no? And that is known as a pitot tube. Have you seen such kind of things on the plane? आपने देखा है कि नहीं देखा होगा? And if you have seen that, the name of this thing is the pitot tube. Now here you have a question, sir, how does this pitot tube work? So here it measures the velocity. So as I told you, in some cases we are going to measure the velocity. In some cases we can measure the flow. Everything is possible with the help of the system. Let me show you how does this system work. So here we are going to put one tube. Just look at this tube which is on your screen inside the pipe. And if you can see that here there are two holes over here, three holes. One hole is over here, second hole is over here, and third hole is over here. Now how does this system works? When the liquid which is passing from the pipe, this liquid will directly go inside this pipe from this line, and the liquid will pass over from this surfaces, and the flow of liquid will create the pressure in this pipe, and the two pressures which are created that are known as the total pressure and the static pressure. So difference between these two pressure can be used to find out the pressure in your system, and thereby you can get the answer. Just look at the one more answer on your screen. So here as the flow of liquid, just look at when the flow of liquid increase हो रहा है, जब भी જ્યારે પણ આ flow liquid નો flow વધે છે ત્યારે તમે આ level ને observe કરો. Just observe the level and the flow of liquid during on your screen. You will come across that what is changing. Any doubt, any query? How does this pitot tube work? Let's look at one more example of the pitot tube, which is on your screen. These are the various diagrams which will help you to understand the basics of the pitot tube. So basic application is to find out the velocity of your fluid. Basic application. Okay, let's move further in the discussion. અહીંયા સુધી કોઈને કોઈ ડાઉટ હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કરી દેશો. If you are having any query, any doubt, then respond into the chat box. Otherwise, respond so I can go further in the discussion. Okay, let's move further in the discussion. So this is about the pitot tube and the application. Yeah, this is the actual pitot tube. Just look at on your screen. This is the rotameter. It is a very simple construction to measure the flow. And the construction, I think all of you have seen this. Where you have seen this, please let me know into the chat box. તમે આ ક્યાં જોયું છે? કોઈ બતાવી શકશો? Okay, this is widely used in the hospital. આ જે ડિવાઇસ છે એ જે તમારી સ્ક્રીન પર છે એ સૌથી વધારે યુઝ થાય છે હોસ્પિટલ્સની અંદર. And just look at this small ball. So as the pressure inside this increases, this ball will rise up in this tube. When I'm repeating, as the pressure in this pipe is going to increase, so the ball will rise up. So that is equal to the pressure. Okay. And you can even you can even just look at this O2 is mentioned over here. So you can even adjust the flow from in this meter. And how does it work? આમાં આ કઈ રીતે વર્ક કરે છે હું તમને સિમ્પલ રીતે એક્સપ્લેન કરું છું કે આની અંદર તમને એક નાનો લાલ કલરનો બોલ દેખાય છે એટલે જેવું તમે આ ટેપ ઓપન કરશો એવું એ બોલ રાઇઝ અપ થશે અને બોલ જ્યાં સ્ટેબલ થશે અને જ્યાં એ રીડિંગ જે બતાવે છે એ છે તેનું પ્રેશર. Same way here in this construction, what is important? This float will rise. This is known as a float. Float will rise, and float will rise depending upon the position of your, depending upon the pressure of your liquid. And wherever the float stable, that is equal to the flow in your system per minute. તમારું જે સ્ક્રીન પર જે તમને કન્સ્ટ્રક્શન દેખાય છે એમાં ફ્લોટ છે. ફ્લોટ મીન્સ a moving object in the vertical pipe. Float simple meaning છે કે તમારો moving object in your pipe, and as float moves up and down, you can determine the level of or flow of liquid in your system. It is very important. Limitation of this system is that this meter has to be mounted vertically. Limitation of this particular system is that this particular sensor has to be mounted vertically. This is the construction. Just look at this. આનું કન્સ્ટ્રક્શન છે. એકવાર જુઓ શાંતિથી અને 2 મિનિટ આપું છું તમને. એમાં કોઈ ડાઉટ હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કરી દો. Let's move further in the discussion. This is one more diagram. આ એક હજી ડાયાગ્રામ જેમાં તમને ફ્લો મીટર ખ્યાલ આવશે. અગેન મેં તમને લિમિટેશન કીધું કે આ જે સેન્સર છે ને તમારે સીધું જ રાખવું પડે. તમે આડું કરશો અને સિસ્ટમમાં ફિટ કરશો, it is not going to work. These are the different types of fluid. અલગ અલગ ટાઈપના ફ્લુઇડ છે જે તમે આ સિસ્ટમમાં યુઝ કરી શકો છો. And the measurement principle of variable area flow meter. Okay, now let's move to the next part. Now we are going to learn about the new technology which is introduced. હવે આપણે નવી ટેકનોલોજીની વાત કરશું જે ઇન્ટ્રોડ્યુસ થઈ છે ફ્લો મેઝરમેન્ટ માટે. We will talk about the new technology which is used for the measurement of flow. Let's just start the discussion on it. And the new technology which is on the screen is the turbine type flow meter. In this turbine type flow meter, how does this turbine type flow meter work? આ કેવી રીતે વર્ક કરે છે? આની અંદર તમારા ફ્લો મીટર ની અંદર એક ટર્બાઇન હશે અને એ ટર્બાઇન જો ફ્લો ચાલુ થશે એ રોટેટ કરવાનું ચાલુ કરશે. હવે અહીંયા આગળ ટર્બાઇનની જે બ્લેડ છે તમારી મેગ્નેટિક કાં તો સ્ટીલ. ટર્બાઇન has a blades and which can be magnetic or the steel, and the movement of your blade will be picked up by the pickup coil. So as speed increases, your coil, which is the turbine rotor, will rotate at the higher speed, and based on that, the readings will be noted down. So as the speed of the turbine increases, uh, the speed of the rotor is going to increase, and thereby the output which is generated by magnetic coil is going to be increased. Again, I'm repeating. કે જેવી તમારી ફ્લો તમે ચાલુ કરશો તમારા પાઇપની અંદર, અને એ ફ્લો તમારા આ સેન્સરમાંથી પાસ થશે અને એ સેન્સરના રોટરને રોટેટ કરશે. જેવી તમારા ફ્લો વધશે એની સાથે સાથે રોટર છે એની સ્પીડમાં વધશે, અને જેવી રોટરની સ્પીડ ઇન્ક્રીઝ થશે સાથે સાથે તમે જો એની ઉપર વચ્ચે અહીંયા આગળ એક મેગ્નેટિક પિકઅપ પોઈન્ટ મૂકેલી છે જે એની સ્પીડને ડિટેક્ટ કરશે. So the magnetic pickup coil is going to generate magnetic pickup coil is going to measure the speed of the this particular rotor, and that speed is proportional to the we can convert that speed and the volume into the output. Okay, so this is how this system works. If you are having any query, any doubt in this discussion, then let me know into the chat box. અહીંયા સુધી કોઈને કશો ડાઉટ હોય તો એકવાર ચેટ બોક્સમાં રિસ્પોન્ડ કરી દો. Okay. Pressure depends upon the how you are giving the can pressure happen to increase. Yes, dear. Pressure dependent upon the motor, at which motor you are connecting and how you are just creating the pressure inside the tube. Just a minute. I have one more video in which I can show you the construction of this meter. Just let me know. Find out and let me show you.
When paired with a universal the rotor is constructed of titanium.
Just look at this video.
Wide range of crude oils, particularly higher viscosity crude oils, which are beyond the capabilities of conventional turbine meters. The unique two-bladed helical design reduces the boundary layer effect of higher viscosity crude oils on the open area of the meter, thus increasing the meter's measurement range. The meter is also less sensitive to wax and particulates found in crude oils. Its high-accuracy measurement, rugged construction, and wide flow range make Smith Meter MV series turbine meters a cost-effective solution for crude oil measurement, especially when paired with a Universal Performance Curve Compensator, UPCC, for viscosity compensation. Helical turbine meters, like conventional multi-bladed turbine meters, are inference-type meters, in that they infer the volumetric flow from the axial fluid velocity and the cross-sectional area of the meter. As the turbine meter housing is cut away in this animation, we see the two-bladed helical rotor. The rotor is constructed of titanium, which was...
Just look at the rotor, how it is placed between these two.
chosen for its light weight, high tensile strength, and excellent corrosion resistance. The flow stream, depicted by the flowing blue arrows, is channeled by the upstream stator through the rotor. The rotor, like conventional turbines, rotates on a fixed shaft with a virtually frictionless, highly polished tungsten carbide bearing system. The rotational speed of the rotor is directly proportional to the axial flow velocity of the fluid. The fixed shaft tungsten carbide bearing design is the same as the bearing systems used in the Century Series turbines for over 40 years in harsh crude oil service. A high-strength permanent magnet is embedded in the tip of each blade of the rotor. As in conventional turbine meters, a pickup coil is located directly above the rotor and is completely isolated from the fluid. It is constructed of many coils of fine wire that are wound around a core of paramagnetic material. As each blade passes underneath the pickup coil, the passing magnetic field induces an AC voltage in the coil, which is seen as a sinusoidal wave.
Let's look at the working of magnetic pickup coil is very important over here. How this magnetic pickup coil is working with this is very important. Is it clear? ખબર પડે છે કઈ રીતે વર્ક કરશે ટર્બાઇન ફ્લો મીટર? As the flow increases, the turbine velocity is going to increase, and thereby you can convert this turbine velocity into the reading output. Magnetic pickup coil are going to generate the such kind of signals, so we can always convert this into the output.
The sinusoidal wave is then converted by the preamplifier into a square wave pulse stream, as shown. The MV series turbine meter can operate with a conventional preamplifier or with a UPCC, which incorporates a built-in pulse chronometer. Pulse chronometry increases the low-resolution output of a two-bladed turbine meter to a value equal to or greater than that of a conventional multi-bladed turbine meter. Since the flow area is constant and the rotor velocity is directly proportional to the flow velocity, each output pulse represents a precise amount of fluid that has passed through the meter. The continuous pulse stream is then transmitted to an electronic counter or flow computer to indicate both instantaneous flow rate and total metered volume.
So this is about the turbine flow.
FMC Technologies.
I think હવે તમને બધાને સમજ પડી ગઈ. Kelvin, now you're able to understand the working of this one or not? Okay, let's move further in the discussion. This is the one more animation diagram. Just look at this animation. How does this work? Okay, so this is about the turbine flow meter. Let's move to the next part in the discussion. And this is the next construction. This is now we are going toward the technology. Here, what we are going to do, that we are going to mount the coils on the pipe. And they are known as electromagnetic flow meters. So we are going to mount the coils. આપણા જે pipe છે એની પર coil mount કરશું, and we are going to put the probes, and as the velocity of liquid increases, we can measure the flow. So again, this probe. Just look at this probe. આ probe pipe ની બંને બાજુ install કરેલા છે. This is a probe 2. If it is P1, this is a P2 probe 2. So this probes are going to generate the signals. આ probe તમારા signals generate કરશે. And based on the signals generated, they are going to we can conclude the flow which is coming out of the or coming from the pipe. Okay, so this is about the electromagnetic flow measurement system. Just look at the sensors are mounted and એક બાજુ આપણે સેન્સર્સ માઉન્ટ કરીએ છીએ અને એક બાજુ આપણે મેગ્નેટિક ફિલ્ડ ક્રિએટ કરેલું છે. તો આ વચ્ચેનું જે ડિફરન્સ છે એના કારણે આપણને ફ્લો ફાઇન્ડ કરી શકીશું. સો આ એક બીજી એક એરેન્જમેન્ટ છે જેની મદદથી આપણે ફ્લો મેઝર કરીએ છીએ. And it is known as an electromagnetic flow meter. અને કહેવામાં આવે છે electromagnetic flow meter. This is one more arrangement. So we are going to put the one coil on the top of the pipe, one coil in the bottom of the pipe, and we are going to put the probes over here. And as the velocity of your liquid increases or decreases, we can measure that change, or we can measure that with the help of the probe. But the limitation of this method is your liquid should able to have the electrical property of liquid. So આ method ને conductive જોઈએ. So that is the one of the limitation of this system. આ સિસ્ટમની એક limitation છે. I have one video on the rotameter. Let me check it whether I can show it to you or I cannot show it to you. I think it's fine if I'm not. If leave it. So let me show you the pitot tube. I have the one video on the pitot tube. If you are having the, if you are able to see the video on your screen, then respond into the chat box. This is a pitot tube. So this is the construction of the pitot tube. Just look at it. And this is how it is connected to your dashboard. Just look at the connections. Even they are showing in detail. So it has a multiple applications. The measurement of the fluid. Okay, now let's go Further discussion is the electromagnetic flow meter that I discussed with you. Now, electromagnetic flow meter is already has been discussed, and the next is the hot wire anemometer. Now, this is one of the important flow meter. We are going to measure the flow of the liquid, and in the hot wire anemometer, here what we are doing, we are going to insert the two probe. આપણે પાઇપની અંદર બે probe આ રીતે insert કરીશું like this, અને એ probe install કર્યા પછી એકને આપણે કરંટ પાસ કરીને એનું ટેમ્પરેચર ઇન્ક્રીઝ કરીશું અને બીજા એન્ડ પર આપણે એ ટેમ્પરેચર મેઝર કરીશું. So at the one probe we are going to pass the current, and we are going to increase the current, and we are going to measure that particular temperature which is available at the second probe. Now, as soon as the flow increases, the temperature which is measured at this probe will be different. That depends upon the how much flow which is passing from the system. When I'm repeating, તમે જેવું સપોઝ એથી લિક્વિડ પાસ કરશો તો આ લિક્વિડ શું કરશે, લિક્વિડ આની ઉપરથી પાસ થશે, અને જેવું આની ઉપરથી પાસ થશે એટલે તમે જે આની અંદર કરંટ પાસ કરીને જે આનું ટેમ્પરેચર સપોઝ કે તમે 50 ડિગ્રી કર્યું છે એ ઓછું થઈ જશે. એટલે અહીંયા આગળ જે ટેમ્પરેચર મેઝર થાય છે એની વેલ્યુ થઈ જશે ઓછી, અને based on that temperature difference we are going to measure flow. એ ટેમ્પરેચર ડિફરન્સની ઉપરથી આપણે ફ્લોનું મેઝરમેન્ટ કરીશું. આ રીતે આ હોટ વાયર એનેમોમીટર સિસ્ટમ વર્ક કરે છે. ઓકે, so this is the how this hot wire anemometer works. So again, this is one method over here in which we are going to pass the current from the wire, and as you pass the current from the wire, the temperature of this probe is going to increase, and its resistance is dependent upon this wire. The resistance is dependent upon this wire of this probe, and as you change the resistance, its value will be changed, and based on that the galvanometer reading will be affected, and you can convert that change in the reading into the output. So this is how your hot wire anemometer type meter works. Yeah, this is the very recent technology, ultrasonic flow measurement technique. So in the case of ultrasonic flow measurement method, we are not going to obstruct the fluid. Ultrasonic flow measurement method માં આપણે fluid નું flow ને obstruct કરતા નથી, but આપણે શું કરીએ છીએ એ કેસમાં fluid ને obstruct કર્યા વગર flow નું measurement કરીએ છીએ. Without obstructing the flow of fluid, we are measuring the flow. Is it clear or it is not clear? So this is the ultrasonic measurement. Now, how does this method work? Let me know into the chat box. How does this measurement method works? Or how does this ultrasonic flow measurement method works? So in this method, we are going to pass the one signal from the pipe. આપણે પાઇપની અંદર અહીંયાથી એક સિગ્નલ પાસ કરીશું, અને એ સિગ્નલ અહીંયા કેટલી વારમાં રિસીવ થાય છે એ આપણે મેઝર કરીશું. Okay, I'm repeating that in this method of flow measurement, So what we are going to do, we are going to pass the uh, one signal from this end, and we will look at that at what time this signal is received at the second end. And depending upon the flow, we can identify that what is the uh, flow or the velocity of the liquid in this particular pipe. Is it clear or it is not clear? Please let me know into the chat box if you are having any query, any doubt up to this point. Let me explain you the next part. There are the different methods. I'm not going into detail of this because this is very in detail of the electrical. This is a transit time method. Now, what we are doing in the transit time, over the pipe, we are going to install only two sensors, and we are going to measure the this sensor is going to send the signal, and this sensor is going to receive that uh, the send signal. And the time between these two will be able to, or by measuring the time between these two signals, we can conclude that what is the flow in this particular system. Okay, so I have one video on this. So let me show you, so it will be very easy for you to understand this concept. Just wait for a second. Yeah, I have the one that is the related to the electromagnetic flow meter, but I think that I need to no need to show it to you. But ultrasonic, I got it.
Matched noise immunity. Flow meter solution.
Just a second, let me show you. So just look at this meter.
Innovation. Unmatched noise immunity. The Siemens ultrasonic flow meter solution. Best in class performance and day-to-day operation for all liquids and pipe sizes. Sound is a series of mechanical vibrations transmitted through a medium. Given the delay in transit time, some animals use ultrasound with.
So again, this is the method is the ultrasonic. So they are going to send one signal. Ultrasonic means that its speed is very high.
More than 20,000 hertz, not audible to the human ear, to estimate distances extremely well. Think about an object moving in the same direction as a moving sidewalk. It advances at a faster pace than an object traveling in the opposite direction. In a flow system, sound waves behave in the same manner. Combined ultrasonic transmitters and receivers are placed opposite each other. Ultrasonic waves are alternately sent and received by means of the piezoelectric effect, where mechanical.
Okay, so they are going to send the signals and they will look at the receiving time.
Energy is converted into electrical energy through the use of a crystal. When moving in the same direction as the flow, they travel faster than waves traveling against the direction of the flow. The higher the flow velocity of the medium, the greater the difference between the two transit times. Combined with the known area inside the pipe and the measured sonic velocity and temperature of the media, it is possible to accurately measure the volume and also to derive parameters like density and viscosity. As the flow meters have no parts that wear, measurements remain constant and the total cost of ownership low. The inline product family measures with very high accuracy. The sensors are in direct contact with the medium.
So this is how the ultrasonic measurement method. Here, what is the advantage? That we are not obstructing the fluid. Again, second advantage is you can mount this on the pipe directly. No need to cut anything in your system. कुछ भी cut नहीं करना है. Just look at the mounting. Is it clear or it is not clear? Okay, this is how we are going to mount on the pipe, and you will directly get the readings.
Siemens offers a wide range of solutions, from single-path transit time to highly complex multi-path measurements used in demanding applications where performance may be affected by flow profile distortion. If the medium contains dispersed particles or bubbles, Siemens uses a method based on the Doppler effect, a frequency shift similar to a passing fire engine.
So I'm not going any much detail because this will be a very detailed part of electrical. But I have one more video in which I can show you the mountings. Just look at how easily you can mount the system. Here, just they are showing you, I'm showing you, and how you can mount the sensor on the system. Just look at the mounting procedure. Two sensors directly on the pipe and just get the reading. Just look at the. So again, what we are going to they are showing over here that we need to set the distance between these two sensors where they are fixed it, and based on the distance between those sensors, we can fit the distance into the meter, and they will give you the direct reading. So this is how this particular system works. And by setting all these things, I'm not going to detail. By setting the distances where viscosity, તમારા liquidની distance એટલે બે સેન્સર વચ્ચેનું distance કેટલું છે, viscosity છે, એ બધા પેરામીટર્સ તમે આની અંદર સેટ કરી દેશો તો તમને એની વેલોસિટી ઇઝીલી તમે ફ્લો કેટલો છે ફાઇન્ડ કરી શકશો. So this is all about this particular new technology, ultrasonic flow of measurement. If you are able to see slides on your screen, then respond into the chat box. તમારી સ્ક્રીન ઉપર સ્લાઇડ દેખાઈ રહી હોય તો એકવાર chat box માં respond કરી દો. Okay. So this is the different types of ultrasonic flow measurement method. And in this flow measurement method, we are using the basically Doppler and the transit time. Okay. So this is all about the flow measurement. Dear, it's not a lecture, it's a lab because we need to discuss the theory as well as the lab session. So this is combined, so it will up to the 525. But if you are, let's skip the discussion up to this point today. So if you are having any query, any doubt, then let me know into the chat box for this topic. If you are having any query, any doubt, then let me know into the chat box. So as you're not having any query, any doubt, then you can drop your enrollment number into the chat box for your attendance. You can drop your number into the chat box for your attendance if you're not having any query, any doubt. After dropping a number, you can leave the session. Have a good day. We are ending the session up to this, keeping the discussion up to this point. Have a good day.